This is a demo of the R backend for the application I developed. The application uses support vector machines to try to predict crime in real time. So I'm going to go over what R actually does. So I loaded up R here in the terminal, and this demonstration here will show you why we should have any sort of confidence within the classifier. So here I am loading in the library's tables and saved image of the classifier, which was already trained. As you can see, we have two tables, the crime 2008 data in a table and the crime 2009 data also in a table. This is crime, which is binary 0 or 1. This is a lat, this is a long, this is the time of day in which the crime occurred, the date, the visibility, the temperature, and the unemployment rate. Okay, so here is a summary of the classifier I trained previously, and I loaded the image. It took quite a long time to train. So here, as you can see, is the formula, which is crime. We're trying to predict crime, which is the dependent variable on the independent variable. The independent variables are lat, long, time, visibility, temperature, unemployment. And the data we're using for training is the 2009 crime data. Our kernel is an RBF. Our gamma, this was trained previously when we tuned the model. The gamma, which is almost optimal, sort of optimal, is 0.01. The cost is 80. And this is actually a weighted version of SVM. As you can see, there's class weights. Because we have a rare class problem where there's not many crimes. Crimes are pretty rare when you look at space-time hypercubes. We have to weight the crime heavily so that we actually predict crime when crime is actually there. And we also want to train a probability model, so we put that as true. And this gives you a summary of what the trained model looks like. Gives you the support vectors and gives you the number of classes and all that stuff. Okay, so we want to know how good the classifier is on our training data. And I will show you that here. As you can see, this is a two-way table where the rows are the predictions and the columns are the ground truth. And if you look at the diagonal, if you sum up these two numbers, they give you the total, and divide it by the total number of rows within the crime within the crime 2009 data set, you obtain the total accuracy. And our total accuracy is about 62%. That's not too bad. But what we really care about is the accuracy of our classifier when crime really exists, which is much higher. It's at 92.7%, and this is when crime really exists. We're looking at this column right here, and 6,191 times out of the total, which is this plus this, which is 92.7% of the time when crime really exists, our classifier makes the right prediction. And of course, we want to not only have our classifier do well on the training data, but on also a testing data set. So we have this, when we are testing the classifier, we're going to test our classifier on 2008 data. And this is a two-way table if we're trying to predict 2008 from a 2009 classifier. We did this particularly because we still want to leverage 2009 data to predict 2010, which is currently May 1st, 2010. So that's why we're trying to we're doing this type of testing. We can't yet predict on 2010 data because we don't have a complete 2010 data set. But that's just a tangent to our point here, which is our two-way table shows that we actually do pretty well. If you add our total classification rate is the same. You add the diagonal and you divide by the total number of rows within the crime 2008 data set, and we will obtain our total accuracy here. It's about 77–78%, which is pretty good. But of course, what we really care about is accuracy when crime really exists. And we get about 69%, which is pretty good, considering we're testing. We should have a certain amount of confidence that our classifier will do well in a demo in trying to predict 2010 crime. Although, of course, as we're making forecasts, we can't be totally sure. So that finishes the demo on why we should trust SVM.